All right, back again, and now we've got our data, we've done our activity, now we've got to tell everyone what actually happened. So we're going to look for any patterns or trends, and that's really super duper important. When we make our graphs and show our data in graphical form, we must remember not to do certain things. As it says here, too often students get there and simply join the dots. Now, in a lot of instances, the actual dot we see is not really the exact spot. It is approximately where the data should be, but it's not exactly on that spot, so we should make sure that the line goes maybe near, and this is why we use what's called a trend line. Now, most importantly, we must give the graph a suitable title. Don't just simply say something like temperature versus time. Why not tell the reader what is actually happening? Something like, this is how temperature changes as we heat a liquid, or something similar, to give them a really true picture of what you've just measured and what they're actually reading about. The other mistake students often make is by not telling me what the numbers represent on each of the two axes. So make sure your axes have a name and, most importantly, a unit to go with the numbers. A little more on the suitable title. Now you can see here that I've actually given a couple of examples, so we can actually fill in the missing gaps to actually create a really good indication of what the graph is showing us. Don't forget that the title of the graph should exactly match what you really did. So we could do something like, what happens to the mass of magnesium as we change the concentration of the acid? Now, it says it's generic, and it's true, but quite often by simply having something like this, we end up with a very good idea of what's going on. Simply saying temperature versus time or whatever doesn't really tell the reader what's going on. Now, when we label the axes, normally we have the measured axis up the side, so the vertical axis is what we've measured, and the horizontal axis is what we've changed. Now in this case, the person who did this activity was measuring displacement, or what we'd call distance, in metres that something moved over a period of time, and the time the person was measuring was in seconds. Now, early on I said that the line should not go through, or not necessarily go through, the dots, and this is a perfect example. What the person has shown us here is that there is a relationship between displacement and time, and it's a straight line, and the line we actually see is what we call a trend line. In other words, it is showing me an overall pattern that occurs in the data. A really good idea is to include a brief summary or description of your graph underneath. So I've said here you could use a heading or a subheading like trends and patterns in my data, and then you go through and tell the reader what you see is happening. So in other words, you might say the values go up, or in the case of the graph on the previous slide, as the displacement increased over time. Right? Now, we can say it increased in a straight line, it increased quickly, or it started slowly and then became quicker as the time increased, or whatever you describe the changes. But don't forget to say whether it goes up or down. Sometimes graphs are linear, in other words, a straight line is shown, but they go downwards. So the actual value of the y will decrease as the value on the horizontal increases. Now, if they are constant, in other words, if we have a straight line, then we should say that. If they change, we should describe how it changes. As you go further along in the MYP, by the time you reach year 9 and 10, you should be saying at so many seconds it changed, and then it changed again. In that way, we could show where the changes in the gradient or slope of my chart change. Now, each graph tells its own story, and it's got some interesting shapes in the examples I have given. Many of the instances in your science data will be linear. In other words, x is related to y. Right? These show that the independent and the dependent variables are indeed related to each other. So if they're linear, we can say they're directly related. In other words, a change in the independent will cause a change in the dependent. Other common ones are the ones shown here called the exponential and the logarithmic. Now, the exponential shows us as we see a bigger change in the vertical as we go across the horizontal. And the logarithmic shows us we start off with a fast change and then it gradually becomes slower and slower until it becomes constant or flat. Don't forget that you should tell me if they are related or not. Sometimes the variables will not be related. In other words, a change in the independent will not cause a change in the dependent variable. So we would see a certain type of line. But as I said before, in the majority of cases, you are going to see a straight line as your trend line, which means there is a direct relationship between the two variables. So please tell the reader that there is that direct relationship, so they are linked to each other.